You may have heard of Doppler effect from your physics class or the internet. Doppler effect is defined when there's a change in apparent frequency as a result of relative motion between the observer and the source. For those of you who forgot or need a recap, well, let's look at the most famous example, the ambulance passing by.
Not one of the fucking new ones.
Did you notice that? When the ambulance comes closer, the siren seems to become louder and higher pitched faster. However, when it passes by, the sound gets slower almost immediately.
Well, this is because sounds are waves, and waves propagate through medium, and in this example, it is through air. Just look at this animation. When the ambulance moves, as we can see, the waves are squeezed to each other, or you could say the wavelength is shorter, while on the back of it, the wavelength is longer and more spread. This is the case for when the source is moving, while you, the observer, is stationary. Of course, this is not the only case for Doppler effect. There's also the second case where the one moving is you, the observer, while the source stays stationary. Doppler effect still applies here. When you move toward the source, you encounter these sound waves more frequently, while you encounter the waves less frequently when you further from the source. Well, obviously, we cannot run from formula here. Let's see how we can use this formula. By using this formula, we can find the observed frequency, assuming that air is constant, and all speed measurement is made from the relative motion of the observer and the source. Now you might ask, okay, Doppler effect exists for sounds like sirens and voices, but what's the point? How useful is this? Actually, the point is, Doppler effect is not just about sound waves. It also includes other waves such as light waves, water waves, and other mechanical waves such as seismic waves. Did you know in the 1920s, Edwin Hubble observed distant galaxies from a telescope located at Mount Wilson Observatory? He noticed that their spectral lines were shifted towards longer, redder wavelengths. This redshift was explained with the Doppler effect. As it turns out, the universe is expanding uniformly, and it provided strong evidence to the Big Bang theory. Of course, with our naked eye, we cannot notice this effect, but astronomers with their accurate equipment could. In conclusion, for sound waves, the pitch changes to lower pitch when it goes away and higher pitch when it comes closer. While for light waves, however, color shifts towards red when it goes away and towards blue when it comes closer. The article that I mainly refer to make this video. These are the references for this video. Next time you hear that telltale siren shift or gaze at the starry sky, remember, the Doppler effect is whispering the universe secret right in your ear or your eyes. It's a reminder that motion shapes everything we perceive, connecting the chaos of traffic to the birth of the Big Bang.